Generally speaking, Matt, doing the minimum is not time for celebration. Generally speaking. In your case, however, it might be. Good job, Matt, for doing what you're supposed to do. All right. Hey, couple things before we get started. Here's what typically happens in this chapter. We start off by talking about some specific things. How do we show that parts are congruent? Part two different triangles. Show the two triangles congruent. And then call it CP. I'll get nearly everyone will be good on that, right? Or being able to identify, the 5 ways we know how to prove the two triangles congruent. And then the end of the chapter, we get 2 lessons of nothing but proofs, yesterday's and today. Okay? And then the last day, we get some more skill things. And so what will typically happen is that kids will get so beat down by this proof thing, is that we get to the last day and no one pays attention type thing. So I just want you to be aware that yes, it's 2 days of proofs. Today's the second day. I truly do need you to put your best effort forward. But just remember that tomorrow we're going to get a skill thing, and it comes free. It's a challenging skill thing as well too. It's a lot of it. Maybe a 2-day lesson. We'll see. All right. Any specific questions on the homework?
Number 4 written. Yeah, we had 1 through. We had 1 through.
I take back my compliment, man. All right, so number 4 on the written exercises is a proof. And you get this shape that we will get next chapter. We will define as a trapezoid. You just don't know it's a trapezoid. But you're told that this shape, which is a trapezoid, by the way, looks like this. And you get these 2 diagonals. And you are told that O is in the middle, and it goes S-T-A-R, star, S-T-A-R. You are told that RT is congruent to AS. RT, this whole thing right here is, what? AS, RT, AS, sorry. RT, AS. So the 2 diagonals are congruent. And RS is congruent to AT. RS is congruent to AT. So I'm not going to put the tick marks on the diagonals because it would be messy. So the 2 diagonals are congruent. All right. And then you're trying to prove that TSA, STR, TSA, you're trying to prove that one, it's not congruent. I'm writing in red. TSA is congruent to STR. STR. I need to show that. Yeah.
Yeah. Talk about. Like I look at it, I'm just thinking.
It's like you look at this and there's like, well, what could I do? Well, I'm gonna go to the girl that I always go to, Bailey. Look at the shape. There's only one thing that you should recognize inside the shape, and it's a shape. Boom. Sweet. Did you not see the X?
Yeah.
She saw it, right? If you see that X, immediately you know you have vertical angles. I don't know which ones I'm going to use, so I'm going to mark them all. So I'll put, well, that's congruent to that, that's congruent to that. I need 1, 2, 3, 1, 2, 3. Okay. Did that get us anywhere? With any of the triangles that you see, Seth? Did that get us anywhere? Okay, so this triangle, I got a side and an angle, nothing. Wait a minute. Remember, I got that this is congruent to this. This is that perfect chance to use my technique that I showed you yesterday. We only did it for 1 slide, and that's when things are all together, take them apart. I'm going to take this triangle and separate them. So I'll try to draw that as horribly as I can, which that was a pretty good horrible drawing. And this one kind of looks like this. We know that that's congruent to that, that's congruent to that. We know that this angle is congruent to, oh, I got to draw this. Wait, that's not right. This angle, which is right here, is congruent to this angle. And then lastly, both of them have what in common? When you put them together, what do they have in common? The top. So now what do we have?
Yeah.
Oh, crud. Boy, we thought we were going to make some progress, but we got one extra thing. This is the hidden part. The given said that the diagonals were congruent, so therefore our savior, we got either SAS or side, 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 either one. Okay, so the two triangles are congruent, right?
Okay.
Did that help us any?
That's as far as I got.
Okay, so then we can say lots of things, right? We can say that this angle, I'm running out of arcs. When you run out of arcs, you put an arc, you put a tick mark on the arc. Go figure. Now I can say by CPCTC that that angle is congruent to this angle. Did that get us anywhere? With maybe another triangle? How about these triangles right here now?
I do have a question.
What?
How do we know that O is going to be the bisector of our two of our axes?
I don't know if it is or not.
Yeah, I know. So how can we assume that on one side of the O is completely equal to the other side of the O? So,
We don't. It's not part of the proof, by the way.
yeah, it's not.
No.
How far off am I?
All right. So once again, I'm still trying to get to these two. But, oh, we're done. You just showed that this triangle and this triangle congruent by SSS, right? Which means by CPCTC, these two triangles are congruent and you're done. That was easy. If these two triangles are congruent by SSS, then TSA and RTS or STR, however it's named in the book, they have to be congruent because they are CPCTC. That's it. That's the full proof right there. All right, that wasn't too bad. But the key here is separating those two triangles. Would I put that on a test? Absolutely no. Absolutely not. That's a good proof. That's also number 4, so you would think it's supposed to be an easy proof since it's number 4. You'd expect something in the B section to be challenging. Nothing in the A section should be too challenging. As we will find, that's not always the case. All right, anyone else? All right, since it's all proofs, well, we'll go over the classroom exercises. All right, so what was the classroom exercises? Did I give you the
1 through 9.
odds? Okay. So it says, state which congruence methods can be used. So it turns out that number 1, you could either use AAS or ASA, either one. Right? Number 3 is only ASA. Number 5, either SAS or SSS. Number 7, no, nothing. And number 9, nothing. Okay. Seth, go around and grab that for me, please. In my computer. Do I have them up here? I do. What do you know? I was prepared. You get a call. Behind you. You get calls. You get calls. Yeah, you get calls. That's behind you. Hope you'll be late. Matt is so shocked that he actually did his homework. He wants to make sure 100% it was turned in.
Yes.
Matt, all your teachers were talking about you yesterday at lunch. And it was about your lack of homework and about how smart you were, but you don't do your homework. So give us something else to talk about. Let's see, 3-day weekend, yay for us. I do not know if I can get through Friday's class in one class. We will see. Worst case scenario, well, best case for you guys is that I can't get through, and that means no homework and a 3-day weekend. That would be where, that would just mean everything's pushed back one day. But if I do get through the whole thing, then the test will be on Wednesday. Homework, hey, no joke. I seriously need you to spend more than 1 minute looking at these proofs. As you do these 6 proofs tonight during student advisement, certainly ask me for some guidance if you need some guidance. But if you look at it like, I don't know, I can't figure this one out, and you give up immediately, it's just not how proofs are. Typically, the hard and the challenging proofs, you're not going to be able to get it immediately. You got to give it some thought. What would happen if I did this? What would happen if no auxiliary lines needed? It's just the standard techniques that we've been using. In saying that, though, I do want to acknowledge the fact that you will get to proofs that you look at and you're like, I don't know. And then all of a sudden some idiot next to you says something and you're like, no, they're not the idiot, I'm the idiot. Why couldn't I come up with that? That's just kind of the way that proofs are. So no one's an idiot. But sometimes the obvious is not that obvious, if that makes sense. That's the frustrating part of geometry. And I always will tell you that, I've said many times before, is that I'm not going to write a test that you will fail. I'll write a test that you can pass with just skills alone. The proof is what's going to differentiate the A and the B students. There will be 2 proofs on the next test, 2 proofs. Usually it's one to start off, and then from now on it's like 2 proofs per test. The skills will be the rest. All right, we good? All right, here we go. So really, 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 really try to get into the moment and these are some really ugly proofs today, right? Also, these proofs, well, it's part of my presentation. I'm going to say that there's many different ways of solving them. All right, so as the saying goes, there's lots of ways to skin a cat. Get it?
No, that's sad.
Well, that's why. Okay. So these proof, or the proof that I will show you, is one of many different flavors. I'm not claiming it's the only way to solve this proof, but it is a way to solve this particular proof. All right. Notice the shape. We don't know what the name of that shape is yet. Anybody know? Anybody know what the shape is? That is a kite, right? Or it appears to be a kite. We will get that next chapter when we talk about quadrilaterals. The entire next chapter is on quadrilaterals. This chapter is on triangles. The next one's on quadrilaterals. All right, so this looks to be like what's called a kite. We don't know what that is yet. How many triangles are there?
4.
Am I? There are way more than 4 triangles there. There are way more than 4 triangles there. There are more than 6 triangles there as well.
Wow. Show me them.
Well, clearly everyone can see the 4, right? Well, then you got this one, 5, this one, 6, erase. This one, 7. This one, 8. There's at least 8. There might be more, right? But there's at least 8 there. There's 8 triangles. This whole chapter is dealing with show me that 2 triangles are congruent. This is why I showed that, is because I'm going to just pick some of the triangles. It can be done other ways. So if the triangles that I choose were not the ones that you choose, right? Well, then you may do your proof a different method. I'm going to show you a method to solve this. So when it's complicated like this, 2 things. One, maybe I'm going to pull the triangles apart. Generally, when they're not intermeshed with each other, I don't pull them apart. Okay? When they're intermeshed, that's when the triangles literally overlap each other. That's when I typically pull them apart. When they're just next to each other, adjacent to each other, you can usually do the proof without doing that. Secondly, the other technique, when it's ugly like this, I mean, look how much stuff is going on here. I immediately go to the ending of it. Danny, a little bit more paying attention. I'm immediately going to the end of it. And I think about how it ends and how I would prove that. So, Karis, how does this proof end? You just go to the end. How does it end? Just read what it says. What does it say? Go to the end. What does it say? That upside down T means perpendicular. So how does it end? So immediately I'm going to look at A, C, and B, D. Okay, that's the plus symbol in the middle, right? It says that you got to prove they're perpendicular. Well, there's only one way of showing that something's perpendicular. There's only one. How do you show that something's perpendicular? Vertical angles may or may not be perpendicular. There's only one way to show that. What does it mean to be perpendicular? Don't overthink this. What does it mean to be perpendicular? Come on, you guys can do this. It's not I'm not asking for a crazy thing. What does it mean to be if you're perpendicular?
Isn't there like two lines that go up?
That's parallel. It's more than that. It's not that they intersect, it's that they make right angles. So how am I going to show that they're perpendicular? I got to prove that that intersection is right angles. How many angles are in the middle there? 4. So how many do I need to show that it's a right angle? 1. We know by that one theorem, I don't know which one it is, that if you have intersecting lines and one of them is right, what about all of them? Okay, vertical angles are congruent and adjacent angles that form a line are supplementary. So all I need to show is either 3 is right or 4 is right or the unnamed BOC or DOC is right. And I'm done. That's the whole proof. Okay, well, it sounds like it should be an easy thing. I just need to show that something is right. Well, here's a problem. Do you see any, now I realize there are numbers here. Do you see any degree measurements there at all? So how am I going to show if something's 90 degrees if there's no numbers up there? Do you see the problem? How do I show that 3 is 90 degrees if none of them are labeled? No, you can't pull out your protractor. That's a problem. So how do we show that it's 90 degrees? And we're going to pause there until we get an answer. What do you got? Cadence, my second lifeline right there. Right? Cadence says that, well, the only way, if we don't have numbers, like if angle 1 was 60 degrees, maybe we got a chance by doing some adding, subtracting, and figuring out things are congruent. But if there's no numbers there, there's only one way of showing something is right. Say it again, Cadence. You have a straight line. I do, right there. Do you see it? And 3 and 4 are adjacent to each other. Keep talking. They add up to 180. So how do I prove that 3 is 90 with that thought right there? That's the right thought, by the way. So she said, hey, look, 3 and 4 make a straight line and they're adjacent. How do I prove that 3 and 4 are both 90 degrees? No, because they could bisect like that. Say it. Okay, but once again, I could use that if I had another number. If I knew that 1 was 60, maybe I could do that. Or if I knew that angle 3 was 60, maybe I can do something there. But how do you show that's 90? You're almost there, by the way. And those were all good thoughts. How do we show it's 90? So we got that 2 angles that are adjacent to each other are supplementary. So how would I know if one of them was 90? Okay, well, that's how we know that they're supplementary. But how do I show that angle 3 is 90? We know that 3 plus 4 is 180. So how do I show that 3 is 90? Anybody? Thoughts?
Divide 180 by 2.
What would that imply then? And he's right. What does that imply? Why would you be cutting them in half?
So because they come from the vertex.
What?
Because they come from the vertex, right?
Okay, kind of, I see where you're kind of thinking that, but no. Why would we divide something in half?
Smaller.
Agreed. 3 could be the same as 4 if they're congruent, right? If 3 is congruent to 4 and they both make a straight line, then you would divide them by 2, or the supplementary portion divide by 2. That's why they would be equal to 90. All right, you got to tell me if this makes sense. This is a big one. To show that things are perpendicular when there's no numbers. Everybody understand what I mean? There's no numbers up here. Like, yes, there is. There's a 1 right. No, that's a name. That's not a number. right? You get what I mean. When there's no angle measurements and you got to show that something's perpendicular, there's only one way of doing that. And that's when two angles are adjacent and make a straight line. Then the technique is to show that those two angles are congruent. I need to show that angle 3 and angle 4 are congruent. You got to tell me right now, does that make sense? If I show that 3 is congruent to 4, and they're adjacent, and they form a straight line, well, there's only one number that makes that true. That's if the 3 equals 90 degrees. Yes? So what do I got to show again?
The 3 and 4 are adjacent.
Well, we already got that. So what do I need to show now? How are we going to do that? I need to show that 3 is congruent to 4. If two things are congruent, that means their measurements are equal. I need to show that 3 is congruent to 4. Okay, now put your thinking caps on. We already done this at least 6 times in the last 3 days. How do I show that 3 is congruent to 4? You should know this one. We've done it 6 times. I've shown you the slide 6 times. How do I show that 3 is congruent to 4? No one? What?
I have to show that A is a perpendicular line to BD.
No. How do I show in general terms that any two things are congruent?
Oh, their measurements are
Agreed. He's closest one. Put that whole thought together. That's the slide I kept showing you. How do I show that two things are congruent? Step 1. That's step 2. Step 1. Show that these two parts, 3 and 4, are part of two different triangles. Step 2. Show me that the triangles are congruent. Step 3. Okay. This is the 7th time that we've seen this. You guys at some point need to catch on. To show that two things are congruent, what do? Say it, somebody.
You say it and find the two triangles.
We got to show that those two parts are part of two different triangles. Keep going. Show that the two triangles are congruent. And then we don't have to show, once we show that the two triangles are congruent, then we simply say CP, CPC, and we're done. So let's back up. This is a tough one. I need to show that these two lines, AC and BD, are perpendicular. There's no numbers there. So the only way I can do that is to show that the two adjacent angles are congruent to each other. So now we're back to how do you show things, either two sides or two angles are congruent, show that they're part of two different triangles, show that the triangles are congruent, and then claim CPC, and you are done. Okay. So who can tell me what we're doing now? In general terms, what am I going to do here? What am I going to do?
Show that the triangle, there's two different triangles.
Which triangles we want to show?
1, 3,
Triangles.
AOD and AOB.
So Wes said, I want to show that this triangle right there, AOD and
AOB
are,
congruent.
I'm looking at those two triangles. Let's show that those two triangles are congruent, and let me get caught up. All right, given. Right. See the marks given? And to show that, I need to show that these two triangles are congruent. All right. How many congruency symbols do we have on those two triangles right now? What else could we say about that triangle? Which sides? What? Which ones? Okay, in that case, it would be which one? We could say that AO is reflexive. We have an angle, we got a side. We got anything else? We don't know. That's what we're trying to show. We have anything else other than, I didn't mark it yet, a side and an angle. We got anything else on those two triangles? Remember, that's our goal, is to show these two triangles congruent. Say CP, CTC, we're done. We got nothing. We got Alternate interior will only be if we had two parallel lines. We don't have two parallel lines. We do have this though. Here's where it gets even more complicated. You ready? When I say you're ready, that means you're paying attention, you're not doodling, and you're looking at the board. Okay? So this is a case where if you can't prove, and we can't right now, I can't prove that those two triangles are congruent yet. But how many triangles were there up there? And there's 8 of them. Maybe I can prove some other triangle is congruent. And maybe that will get me to where I want to go, which is these two triangles. Oh, by the way, I got an angle and I got a side. What else could we get, what we need in order to prove that the two triangles are congruent? I got this angle, I got this side. If I only had an or that side, if I had this side, I'd have SAS. So if I could somehow show that these two are congruent, I'm there. We got lots of options. Show me that these two angles are congruent, then we got isosceles triangle, right? We got one other option. One of the other, or two of the other 8 triangles up there. You ready? Look at this triangle right there. How many congruent tick marks are on that triangle right now? I got an angle and I got an angle. And I'll check it out. Look at this triangle. I got an angle and I got an angle. I know I just wrote right through all that stuff. What else do you notice about those two triangles? They are, no, they're not, because this is 2 tick marks and that's 1. Right? I know you can't, it's hard to see there. It doesn't say that all 4 of them are congruent. It just says that this one is congruent to 2 and 5 is congruent to 6. What else do you see on the top and the bottom triangles? What do you got, Dan?
ADC is congruent.
Say it one more time. Why? If we, well, right now we have their 2 angles, right? What's reflexive? There is a reflexive there. It's not ADC, but what's reflexive? What do those 2 triangles, the top one and the bottom one, share in common? They share AC. So if AC is reflexive, then I got an angle. The top and the bottom one are congruent. So that's how we start this off. Remember, our big goal is to show that the left top and the left bottom are congruent, but we got stuck. We couldn't get anywhere on that. So we go to maybe 2 other triangles. So I'm going to show that the top triangle, the big one, and the bottom triangle are congruent. Why? Because, well, that's reflective now. I have an ASA. So what Danny said is true. ABC is congruent to ADC. Why? Because of ASA. And you're like, well, I don't know what you're doing now. Well, I got 2 triangles now are congruent. The top one and the bottom one. If 2 triangles are congruent, now all their corresponding parts are congruent. So of the 2 triangles, the top one and the bottom one, what could we mark now?
3 and 4.
You can't, because 3 and 4 are not part of those 2 triangles. What do you got? We could say now that that angle is congruent, and I should put 3 arcs, right? It's congruent to that one, but I'll make them in black. We could say that now, but remember, our goal is to get to left and right triangles, so maybe we won't use that. But that is true. What else could we say? What other parts of the top and bottom triangle are congruent? A what? Okay, but we had that because of that right there. We already said that. What other parts? You got to look at the top and the bottom triangle. What other parts are congruent by CPCTC? The top and the bottom triangle. What? Okay, we got this one. We got AB is congruent to AD, and we're there. Check it out. Now look at the top left and top right bottom triangle. I didn't mark this because that's reflexive. 1, 2, 3. We got an S, A, S. And we did it. Right? So I could say that AB is congruent to AD by CPCTC. Right? Further, I can now say that AO is congruent to AO by reflexive property. And the rest of the proof just falls right into place right there. Now I get that this triangle right here is congruent to this triangle right there. And remember, our goal was to show that 3 is congruent to 4. Once again, because of CP, and then we're done. If 3 is congruent to 4, and they're adjacent, and they make a straight line, that means they are congruent to each other, and therefore, that means they're 90 because they're supplementary to each other. And we're done. You might think that's the hardest proof we did. Actually, the one yesterday was much harder because we had to draw a bunch of auxiliary lines. Is this something that you could do maybe by the end of year? Okay? We're not ever stopping doing proofs the entire year. It's only the first week of October. Okay? But I will absolutely admit this is a hard one.
For the rest of this year, the rest of the year,
No, I'm just saying by the end of the year, you would be able to do that. Would be an easy proof by the end of the year.
by the end of December.
Maybe. All right, write this down, please. There are many different forms of proofs that you will see this year. We have only been seeing one type of proof so far. That's called a 2-column proof. If you take math in college, rarely will you ever see a math professor use a 2-column proof. It just doesn't. No one thinks it. The reason why high school you're taught with a 2-column proof is it separates things really nicely. And you get to read one statement at a time. There's another type of proof. I love these proofs, and it's called a paragraph proof. And a paragraph proof is, well, it's the same stuff. It's the same logic. It's the same order. You just use everyday words. You just focus on the things that you need to tell people. We know that things are congruent if the two triangles are congruent by CPCTC. Well, I can't talk. By CPCTC. So sometimes in a paragraph proof, you omit things that are obvious. It's kind of like me sitting you down and just telling you a story. Normal sentence structure is used. That means you capitalize and you put periods. You put commas. And you just talk. Right? Paragraph proofs generally focus on just the main ideas. We leave out the details. Sometimes we don't even state the reasons. Hey, I may show that you have SAS and leave out the fact, therefore, the two triangles are congruent by SAS, because I just showed that you have an S and A and an S. It's kind of a free-for-all in the sense of you are the author of your poem or your short story type thing. I'll take the same proof that we just wrote. There it is in paragraph 4. Okay? And you might say that that looks more challenging, and actually, it's you telling the story. It actually is easier. I'm not going to go over the whole thing, but you can read parts of it. That's a paragraph proof. So some high school math geometry teachers have you write paragraph proofs. Some don't. I'm one of the ones that says it'll be okay. If you want to pursue mathematics in your future in college, you'll be fine with a paragraph proof. You do need to be exposed to it. I'll show it to you a couple times during the year, but not much. But to write a paragraph proof, everyone can do it. If you know how to do a proof, you can write a paragraph proof. You just write a paragraph. You start off with the given and you work your way down the proof with sentences. So no, you will not write a paragraph proof in my class. But if you, like I said, you pursue higher level mathematics in college, you will be asked to write, and no one writes 2-column proofs in college. Yeah. You can do paragraph proofs, absolutely. But you better follow the order, right? All right, once again, lots of ways to skin a cat. I'm going to show you another proof that has many different ways of doing it. All right, here we go. Box 3.
No, it's not. No, it's not. No, I like it.
All right, so this says, once again, it looks complicated. For me, my eyeball always focuses on the end. So, Karis, what's the end? It's not a line, that's a segment. Okay, I'm going to ask, and I'll be very disappointed if you can't give me the answer. How do we show that 2 parts are congruent? Step 1. Show that the 2 parts are parts of a triangle. Step 2. Show me that the 2 triangles are congruent. Step 3. And you're done. Okay? So I need to show that AS is congruent to DT. So here's AS, here's DT. Are those 2 sides part of a triangle? In fact, they're part of 2 different triangles. So this is why this one's a little bit more challenging. because you have two different triangles. So our goal is to show that those two parts are congruent. Okay, show that they're part of two different triangles and show me those two triangles are congruent. Wes, pick some triangles. Which one you want to prove?
ABS and DEP.
Let's see if we can show that the two left triangles are congruent. Okay, everybody see what we're drawing? What tick marks do we already have there?
The one on the left side. And the
We
one
got
on
a
the
side and a side. Do we have anything else on those two triangles? You're like, yeah, there's a mark right there, but you got to be careful. It said angle BAC. That's the whole darn thing. So in fact, on those two triangles, all we got is one side. That one's going to be tough to show that's congruent. Okay? We don't have anything else, by the way. So maybe we need to go to the other triangles. All right, let's try the triangles on the right. Maybe we can show something there. Hey, we got lots of tick marks there. Guess what we got there? We got a side and a side. We got anything else?
Yeah, I got another side.
Yeah, but is it congruent?
Yeah, shares with the other side.
Agreed, but this is all we got right here. Can I say anything about this side? What? What can I say about it?
That it's the same side between both triangles.
We don't know. That's what we're trying to prove, by the way. That's literally what we're trying to prove, is that that is congruent to that. There's no other information there. So even though we have an S and an S, we have no angles there. Okay, this one right here refers to the large angle. ED, whatever that is, F, EDF, and BAC. So we got two sides and we don't have any angles. Are there any other triangles up there?
EDF.
I got the big triangle. Check it out. I got this big triangle and this big triangle. Well, let's see what we got for that. I got a side, side. What else?
And the side.
Side angle
I don't have side angle side. I have ASS.
The left side.
The big triangle.
Oh, I have a side angle side. See how you can get confused if you don't look at the right triangle? So make sure you're looking at the right triangle. So on the big triangle, we have a side angle side. Therefore, we can, maybe that's the way we got to go. In fact, that's the only thing we got so far. So that's a lot of given. So we can say that the big triangle is congruent to the other big triangle by SAS. Where are we trying to go? We're trying to go that we need to show that the middle parts are congruent. The middle parts are part of the triangles on the left and the right. Now choose wisely which one you want to go to, the triangles on the left or the triangles on the right. Which one do we know the most about? The ones on the left or the ones on the right?
One there.
The ones on the right. If somehow we could show that this angle, angle F, and angle C are congruent, we got another SAS. What did we just prove right here? The two big ones are congruent. So if the two big ones are congruent, all their corresponding parts are congruent. What do you know about C and F? They're corresponding to the big triangle. So we could immediately say by CPCTC that C is congruent to F. And we're there, kind of, sort of, with a couple extra steps. Everybody see where I got that from? C is congruent to F. Why? Because we just showed that the big triangle is congruent to the other big triangle. So by CPCTC. Go ahead, finish it up.
You're given wrong.
Is my given wrong?
Oh yeah.
Is it S instead of a C?
And then how do you get SAC from,
Where?
because it says BAS is congruent to SAC. It's nowhere in the given.
Yeah, but even
Yeah.
DT, it's congruent to TDF.
Are you saying the given is wrong or this statement's wrong?
That statement.
Okay, yeah, let's fix that. All right,
Did you sleep
It's
while
not even
doing
close.
this?
Yeah,
I could've.
it's like,
God, that's not.
and I had a mini stroke or something. All right, these are not the droids you're looking for. All right. Okay, so we got this angle, therefore the angles on the right are congruent by SAS. And how does the proof finish? By CPCTC, and you're done. Is this now the 9th time that you've seen this proof? Right? Just the previous one the same way. To show that two parts are congruent, show that the parts are part of two different triangles, show that the triangles are congruent. write your given statement correctly, unlike what I just did, and then show that just call out CP, CTC, and you're done. All right. Had enough? Oh no, there's more. I think this is the last one, right? Last one? Or is it two more? Two more, okay. This one, once again, looks like a bow tie. If there's one to mess up, it's this one, and I'll show you why when we do it. Okay, what are we trying to prove, Karis? So what is now going right back to you? Okay, now you've seen it 9 times. What's the technique to show that two parts are congruent? Step 1. You've seen it 9 times. We've done it 3 times today already. Okay. When the teacher says something like you've seen it 9 times and you are still lost, do you have a problem? You have a problem. Admit to yourself you have a problem. Bailey, tell me, how do we show that two parts are congruent? 3 steps. When the teacher says we've done it 9 times and you still can't tell me the answer, the steps, you have a problem. You need to write it down. You need to write this down. Amaya, help us out. What are the 3 steps? Show that those 2 parts are part of 2 different triangles. Step 2. Show me that they're congruent. The 2 triangles are congruent by, any one of those 5 things, SAS, ASA, AS, whatever I left off, and hypotenuse led. And then the last step, you just say CP, CTC, and you're done. This is the 10th time you've seen this. You have a problem if you can't tell me the 3 steps. You have a problem, not me. I don't mean it like that. That's kind of cruel, but I'm just trying to make a point that we've done it so many times, you should be able to tell me the 3 steps. Did I say, can you do the proof? No, I didn't say that, but I said you should be able to tell me the 3 steps. Woo, okay, AX, where is AX and AY? Oh, they're in the middle. How many triangles do you see?
4. 6.
I think it's 6, is that right?
Yeah,
6?
yeah,
Okay, there's 6 different triangles. We got lots to choose from. Ultimately, we need to show that AX is congruent to AY, so therefore they're part of some triangles. Clearly they're not part of the big triangles, right? They're part of the smaller triangles. The part you got to be careful is, look, 2 tick marks, 2 tick marks. 1 tick mark, 1 tick mark. Look at me. The bow tie has been flipped over, right? 2 is now on the bottom, 1 is now on the top, or vice versa, however you want to look at that, right? They took this and they took one side and flipped it over. Does that make sense? Okay. What can we do here?
You could probably say the A is the midpoint.
You could say that. Very good. I didn't even see that. Very nice. Not sure if that gets us anywhere, but maybe it's something I don't see. Yeah, A is absolutely the midpoint of LN and PK and XY.
So if A is the midpoint, can you say X and the line A, X, A, and
So here's the only issue is that we don't know if that's true for XY. We certainly know it for PK and LN.
if it's true for PK and LN, how do we
You would think so, wouldn't you? The issue is this. We don't know if this line goes like that and then like that.
Excuse me?
Yes, ma'am.
Will you send Madison to the office real quick?
She's on her way.
Thank you.
What do you got?
PAL, angle, PAL, angle, NAK,
Boom. I was going to call him Bailey, but you got it before she did. All right. You see the X? Oh, by the way, there's lots of X's there. She said, let's just look at the big triangle, the one on the right, the one on the left. I did that backwards, but you get it. So she said that, let me catch up here. Grammar Nazi, check my work here. So she said that we got vertical angles so that we could call out vertical angles. I agree. That would be my first step.
There's an angle sign.
What?
There's an angle sign on
Thank you. Grammar Nazi number 2. Boy, I'm going to have great looking classes for next year. Right? No mistakes. This is year 2 from this book, so there's still going to be mistakes. Formatting errors, hopefully not math mistakes. Okay, good one. So what can you tell me about the big triangles on the left and the right now? Because of, you ever see that? So the big triangles are grouped because of SAS. Now we can say CPCTC. Does that get us to the middle? It doesn't, but it can get us to maybe some of the other triangle parts. So let's see. If the big one's congruent to the big one, now we got to pick the two triangles we want to actually show are congruent. So which two triangles do you want to show are congruent to get to the very end? You want to show top to bottom, left to right, or you want to show top to bottom, right to left? Either one's fine. Pick one. Top to bottom, left to right. So I want to show that this triangle is congruent to this one for the aforementioned reason that the bow tie has been flipped, right? Because you see where the two tick marks is, now the two tick marks are on the bottom. So I'm not going to show that this one is congruent to this one. I'm going to show that this one is congruent to this one. I'm going to erase that next. Okay? We just showed that the big triangle on the left is congruent to the big triangle on the right. So what are the corresponding parts? What are the corresponding parts of big to big? What do we got? Yeah, well, we already had that because of vertical angles.
L and N.
What is it?
L and N. Is there-
Well, yeah, and the tick marks are already there. What did you say? P and K, right? There'd be corresponding of the big triangle. So we could say P, I'm going to do two arcs. P is congruent to K. And we can also say that L, but wait a minute, we said we were going to mess with the other triangle. By the way, guess what you just showed me? Let me catch up. Guess what you just showed me? Cadence is on fire today, right? She should be wearing a red shirt, not a purple shirt, right? She showed me ASA. So the two triangles that we wanted to show are congruent because of ASA. Yes? So we're done. That was easy. Easier. Of the proofs we've done, this was the easiest one. If you're going to make a mistake on this one, it's generally as a student would look at this triangle and this triangle because it would make sense that they would be congruent. They're not because of the flipping going on. Okay? That one wasn't too bad. All right, last one. This one kind of looks like the previous, right? Where you got 8 triangles going on here, right? Same technique. What do you got?
It's an isosceles triangle. If you take-
Oh, I definitely see an isosceles triangle, right? I see at least one. Oh, wait. Yeah, it's isosceles. Yeah, it is. Okay. What are we trying to prove? 3 and 4. So which triangle would we like to show is congruent? Or the top and the bottom, right? Either the top's congruent to the bottom, then we could say CPCTC, 3 and 4, or maybe the top right and the bottom right. If we could show those are congruent, we could say same thing. Okay, but we do need to show that 3 is congruent to 4. Okay. Of the 2 triangles you see up there, which one can we prove are congruent? Let's use his idea. Isosceles triangle. So if you have an isosceles triangle, what do we have?
The opposite sides are congruent.
Opposite angles are congruent. Those are what? Oh, it's not an isosceles triangle.
But the
It's not an isosceles triangle. Look at the shape. It's actually this shape right here. That's what you have. That's not an isosceles triangle. If we drew an auxiliary line there, maybe. Okay, we didn't get through this one. That's enough.
Again, the homework tonight?
Oh yeah. We just didn't get through this one proof.
It's like
Significantly easier than what
They're
we
significantly easier.
yeah. Michael, did you touch the dab in number 6?
Yeah.
I hope they didn't do that on purpose because I would die.
Yes, that's what
I can't see it now. I can't see it now. I see it. showed me to it like you showed me it like 6 times. I haven't seen it. I don't see any change from that to last time. My mind is dead right now, completely and totally. Sanity is gone.
All right, now it's perfect.
Keto.
That cat is so deformed.
That's just a munchkin. They are horrible.
Those eyes, though. Damn, it's a face only a mama could love.
No, I mean, cat lady, sure. If that's what you need.
No, even I don't like that cat.
You're a cat lady?
I love cats. I have 4.
Cool. I used to have like 10 or 20 on there. Freaking fun. Started a cattery. Almost. Yeah.
I have 4 pets. You just had 20 grand.
No, I mean like pets. Selling them as pets. Which means you had a
Yeah, but you didn't become attached from selling. So you're not pets. Or am I just saying that wrong?
Leave so the other kids can come in.
My brain is just so dead right now. I don't even know what I'm doing. And I've lost my English homework. But I was also actually going to turn in.
Come on in.
Mr. Chartier.
What's up?
Just